97 factorial is divided by 101. Just now we discussed these optimal techniques are useful. P minus 3 factorial. P minus 3 factorial when divided by P is P minus 1 by 2. When P is a prime number. So these are nothing but 101 minus 3. 98 factorial divided by 101 is 101 minus 100. 100 by 2 is 50. 98 factorial is nothing but 98 into 97 factorial divided by 101 is 50. 98 divided by 101 is 98. 97 factorial divided by 101 is x. When divided by 101, remainder is nothing but 50. 98x when divided by 101, remainder is 50. Remainder is 50. Dividend equivalent to divisor into quotient plus remainder. So 98x equivalent to 101k plus 50. 98x equivalent to 98k plus 3k plus 50. 90x 80 is divisible by 98. These also divisible by 98. 3k plus 50 is divisible by, should be divisible by 98. So k value will be 16. K value will be 16. So here it will become, if I substitute 98x equivalent to 101 into 16 plus 50. So x is nothing but 1666 divided by 98. 98 ones are 98. 98 ones are 98. So 2, 686. 686. Whatever the answer that you will get, that itself is the answer. I hope it is clear, right? Idea clear? P minus 1 factorial by P we did it. P minus 2 factorial by P we did it. P minus 3 factorial by P is P minus 1 by 2. I hope the idea is till here clear, right? So what we got? 98 divisible by 98. 3k plus 50, 98. K is 16. So 16 plus 50. 1666 divided by 98. Whatever the answer that you will get, that itself is the answer. So 7 14s are, 7 2s are 14, 26, 7 3s are 21, 8, right? So 14, 17s are, answer is 17, right? You can deduce your own P minus 4 factorial by P. How much? Just by few observational analysis. I hope the idea is clear. Next one, find the remainder when 17 factorial is divided by 23. We are still going very deep. Find the remainder when 17 factorial is divided by 23. We know the logic that remainder when P minus 3 factorial when divided by P, it is nothing but P minus 1 by 2 when P is a prime number. When P is a prime number. So this will become 20 factorial by 23. It is nothing but 22 by 2, which is 11. 20 factorial is nothing but 20 into 19 into 18 into 17 factorial when divided by 23. It is 11. 23 ones are 23 minus 3. 23 ones are 23 minus 4. 23 ones are 23 minus 5 into x when divided by 23 is 11. These remainder of 60x. 23 3s are 69 minus 9. Minus into minus 9. 9x divided by 23, it is 11. I hope till here it is clear. P minus 3 factorial when divided by P is P minus 1 by 2. 20 factorial by 23 is 22 by 2, which is 11. 20 factorial is 20 into 19 into 18 into 17 factorial by 23. 23 ones are 23, minus 3, minus 4, minus 5 into x divided by 23 is 11. 60 is 23, 3s are 16, 9, minus 9. Now from here you can solve this one. 9x is nothing but 23k plus 11. So 9x is nothing but 18k plus 9 plus 5k plus 2. Divisible by 9, divisible by 9, divisible by 9. 5k plus 2 should be divisible by 9. It cannot be 9 because k value will be fraction. It cannot be 18. It has to be 27. So k value is 5. 5k plus 2, 27, k value 5. Substitute there. If I substitute there, 9x is 23, 5s are 115 plus 11, 126. So x value is nothing but 14. X value is nothing but 14. Very, very good quality questions from the topic reminders based on factorials we are discussing. 17 factorial divided by 23. 20 factorial divided by 23 is 11. 20 factorial is 20 into 19 into 18 into 17 factorial by 23. 20 by 23 is minus 3, minus 4, minus 5 into x divided by 23 is 11. 60 divided by 23 is 23. 3s are 16, 9. Minus of minus is plus. 9x divided by 23 is 11. 9x is 23k plus 11. 9x is 18k plus 9 plus 5k plus 2. Divisible by 9, divisible by 9, divisible by 9. 5k plus 2 should be divisible by 9. The only value which will be of the form 5k plus 2 and divisible by 9 is 27. K will become 5. Substitute it, you got x value 14. Starting from basics to an high level. Next one, find the remainder when 23 factorial is divided by 17. 23 factorial is nothing but 23, 22, 21 and so on up to 17 and so on up to 1 when divided by 17. Any number multiplied by 17 when divided by 17, answer is 0. Or in other words, you can easily say that remainder when x factorial divided by n is 0 if n is a factor of x factorial. If n is a factor of x factorial, remainder when x factorial divided by n is 0. Remainder when x factorial when divided by n is 0 when n is a factor of x factorial. I hope this idea is clear. Idea is clear, right? X factorial divided by n is 0 when n is a factor of x factorial. Another question. Now we will discuss the next level of questions. Find the remainder when 18 factorial is divided by 437. First we have to factorize 437. 437 is 19. 2s are 38, 57, 19, 3s are 8. 437 is 19 by 23. So what are the concepts that we are going to use here? Remainder when 18 factorial by 19 we have to do, and remainder when 18 factorial divided by 23 we have to do, and then we have to find the equations. So 18 factorial divided by 19 is nothing but 18. P minus 1 factorial when divided by P. 18 factorial divided by 23. 20 factorial divided by 23 is nothing but 11. Why? Because it is of the form P minus 1 by 2. 20 factorial is 20 into 19 into 18 factorial divided by 23, it is 11. 20 divided by 23 is minus 3. It is minus 4. 18 factorial divided by 23 is x. When I further divide by 23, remainder is 11. Minus into minus plus. Remainder when 12x divided by 23, it is nothing but 11. So here it is dividend equivalent to divisor into quotient plus remainder. So here it is 12x is nothing but 24k plus 12 plus or minus of 1 plus k. Till here it is clear. 12x equivalent to 24k plus 12 minus of 1 plus k. Till here it is clear, right? 12x is nothing. When divided by 23, remainder is 11. This I wrote it as 12x equivalent to 24k plus 12 minus of 1 plus k. Right? These is divisible by 12. These is divisible by 12. These is divisible by 12. 1 plus k should be divisible by 12. That means k value should be 11. K value should be 11. So 12x is nothing but 23 into 11 plus 11, which is nothing but 24 into 11. So x value is nothing but 22. Are you all with me? X value is nothing but 22. That means two equations we got. 18 factorial divided by 19 is 18 we got. 18 factorial when divided by 23 we got it as 22. Now we will try to solve these two equations. 18 factorial divided by 19 is 18 we got. 18 factorial divided by 23 we got it as, how much we got? 22. So both the equations are 18 factorial when divided by 19, remainder 18. 18 factorial when divided by 23, remainder is 22. So if I equate both the equations, 19a plus 18 equivalent to 23b plus 22. So 19a equivalent to 23b plus 4. These is nothing but 19a equivalent to 19b plus 4 into b plus 1. Divisible by 19, divisible by 19. 4 into b plus 1. 4 is not divisible by 19. B value is 18. B value is 18. If B value is 18, answer is nothing but 23 into 18 plus 22. When divided by 19, I will get the answer. Are you all with me, sir? So 23 into 18 plus 22. How to find out the value of B? Is it clear, right? 18 factorial by 19 is 18. 18 factorial by 23 is 22. Both will represent same number. 19a plus 18, 23b plus 22, 23b plus 4. 19a is 19b plus 4 into b plus 1. Divisible by 19, divisible by 19. B is 18. If B is 18, 23 into 18 plus 22 divided by, not 19, divided by 437. Whatever the value that you get it, that itself is the answer. This question is a combination of the product of two prime numbers 19 and 23. This is a combination of two prime numbers 19 and 23. I hope the logic is clear. Another one. Find the remainder when 216 factorial. Now if you see remainder when p minus 1 factorial when divided by p. This is nothing but p minus 1 when p is a prime number. Same concept we will use it here. 2016 factorial power 2015 factorial divided by 2017. 2017 is a prime number. I will tell you in prime number session 1 how to check whether a number is a prime or composite. This is nothing but p minus 1. So these 2000 p minus 1 factorial divided by p, it is nothing but p minus 1. So these is nothing but remainder of 2016 power 2015 factorial divided by 2017. 2017 ones are 1 minus 1. This is an even number. Minus 1 power even number is plus 1. Minus 1 power even number is plus 1. minus 1 power even number is plus 1. Idea clear? Reminder, when p minus 1 factorial divided by p, it is p minus 1. 2016 factorial by 2017 is 2016. 2016 by 2017 is minus 1. 2015 factorial is an even number. Minus 1 power even number is plus 1. Another variety of question. Another question. These are all very, very good questions, sir. Question is, find the remainder when 8 factorial whole square divided by 17. 8 factorial whole square divided by 17. I will solve the first one, second one you can try it out. 15 factorial divided by 17 is 1. 15 factorial is nothing but 1, 2, 3 and so on up to 8 into 9, 10, 11, 12, 13, 14, 15 divided by 17. These also 1. 1 into 2 into 3 till 8 is nothing but 8 factorial. Are you all with me? 9 divided by 17 is minus 8. 10 divided by 17. 17 ones are 17. Minus 7. 11 divided by 17 is minus 6. 15 divided by 17 is minus 2. When I further divide, remainder will not change. From 2 to 8, there are 7 negatives. 7 negatives, if I multiply, it will be negative. So, minus remainder of 8 factorial whole square divided by 17 is 1. So, minus, if I do it, 1 will become minus 1. Minus 1 means it becomes 16. Answer for this question is 16. Answer for this question is 16. I hope the idea is clear. 8 factorial whole square divided by 17. 15 factorial divided by 17. P minus 2 factorial when divided by p is 1. 15 factorial is 1 to 15. 1 into 2 into 3 till 8 is 8 factorial. Minus 8, minus 7, minus 6, minus 2. 2 to 8 there are 7 negatives. 7 negatives, if I multiply, I will get negative sign. 8 factorial into 8 factorial, 8 factorial. Minus is outside. If I multiply by minus 1, I will get positive remainder is 16. Positive remainder is 16. Idea clear? One more question which we will solve. Remainder 1. 35 factorial whole square when divided by 71. 35 factorial whole square divided by 71. So, these are nothing but 69 factorial divided by 71 is 1. P minus 2 factorial when divided by p is 1. 69 is nothing but 1 into 2 into 3 till 35. Remaining will be 36, 37 till 69. When divided by 71, it is 1. 1 into 2 into 3 till 35 is 35 factorial. 36 divided by 71 is minus 35. 37 divided by 71 is minus 34. 69 divided by 71 is minus 2. Divided by 71, it is 1. 2 to 35, there are 34 negatives. If you multiply 34 negatives, I will get a positive. So, answer is nothing but remainder 1. 35 factorial whole square divided by 71 is 1. 35 whole square divided by 71 is 1. The difference between this question and previous question is, there I got odd number of negatives. Odd number of negatives, if I multiply, I will get a negative. Even number of negatives, if I multiply, I will get positive. Very, very quality questions. All the questions are based on reminders, based on factorials. 69 factorial divided by 71 is 1. 1 into 2 till 35. I did till 35 because the question is till 35. 36 to 69. 35 factorial. 36 by 71 is minus 35. Minus 34. 69 by 71 is minus 2. From 2 to 35 there are 34 negatives. 34 negatives, if I multiply, I will get a positive. Idea clear, right? Another question. 270 factorial whole square divided by 541. 541. Now see here. Reminder 1. 270 factorial whole square divided by 541. So this will become, if I do 2, 539 factorial divided by 541, it is nothing but 1. 539 factorial divided by 541 is 1. 539 can be written as 1 into till 270, 271, 272 and so on up to 539 divided by 541, it is 1. So here it is nothing but 1 into 2 till 270 is 270 factorial. 270 factorial. 271 by 541 minus 270. I hope it is clear. It is minus 269 and so on up to 539 divided by 541 is minus 2 divided by 541. From 2 to 270, there are 269 negatives are there. If you multiply odd number of negatives, I will get a negative. So outside minus will be there. Minus of 270 factorial whole square by 541, which is nothing but 1. Multiply with negative on both the sides. Answer for this question is 540. Answer for this question is 540. I hope the idea is clear. First we are doing p minus 2 factorial divided by p is 1. From there we are trying to find out the squares. Answer is 540. This question and previous two questions are of the same model. I hope the idea is clear. Next one, find the remainder 1. 1 into 1 factorial, 2 into 2 factorial and so on up to 45 into 5 factorial. In session 1 we discussed n into n factorial, n equivalent to 1 to n. It is nothing but n plus 1 factorial minus 1. I gave the proof in the first class. So this is nothing but 45 into 45 factorial. It is n equivalent to 1 to 45. This is nothing but 46 factorial minus 1. So here it is nothing but when you divide 46 factorial minus 1 divided by 47. These p minus 1 factorial. P minus 1 factorial when divided by p, it is nothing but p minus 1. So 46 minus 1. Answer for this question is 45. Answer for this question is 45. I hope the idea is clear. N into n factorial, it is nothing but n plus 1 factorial minus 1. 45 into 45 factorial is 46 factorial minus 1. 46 factorial minus 1 when divided by 47. P minus 1 factorial divided by p is p minus 1. So 47 minus 1 is 46. 46 minus 1 is 45. Idea clear, right? Same, another model. N into n factorial. From n equivalent to 1 to n is nothing but n plus 1 factorial minus 1. So these are nothing but 14 into 14 factorial. N equivalent to 1 to 14 is nothing but 15 factorial minus 1. Now the difference is 2. Remainder 1. 15 factorial minus 1 when divided by 17. This is 1. Why? Because remainder 1. P minus 2 factorial when divided by p, it is 1. 1 minus 1, 0. 1 minus 1 0. I hope the idea is clear. Previous question it is p minus 1 factorial by p. Now the question is p minus 2 factorial by p. Variety of questions we are solving under that subtopic. Reminders based on factorials. Reminders based on factorials. I hope it is clear. One more question. There is a number 1 plus 1 by 2 plus 1 by 3 plus 1 by 4 and so on up to 1 by 23. It is a by 23 factorial. So a will become 23 factorial plus 23 factorial by 2 plus 23 factorial by 3 plus 23 factorial by 4 and so on up to 23 factorial by 23. This entire number, remainder when a is divided by 13. So this is nothing but remainder when 23 factorial divided by 13. 23 factorial is divisible by 2. This is divisible by 3, divisible by 4, divisible by 23. So what is left in the final question? 23 factorial should be divisible by 13. If it is divisible by 13, what will be the remainder? The entire question is this one. 23 factorial divided by 13. Now how to solve? Now how to solve this question? Now how to solve? Now see here, this entire question can be translated into, this entire question is translated into 23 factorial divided by 13. Now we will solve it. 23 factorial divided by 13. 23 factorial, what does it is? 13 a factor of 23? Yes. So 23 factorial, 13 is a factor of 23 factorial. So the remainder is 0. Remainder is 0. I hope it is clear, right? So you can do one by one all the questions, sir. Remainder 1. 23 factorial is divided by 13. 23 factorial contains 13, 0. 23 factorial divided by 2 into 13. 23 factorial contains 2. 23 factorial contains 13. 0. 23 factorial divided by 3 into 13. 3 will come in 23 factorial. 13 will come in 23 factorial. Remainder 1. 23 factorial divided by 23 into 13. 23 factorial contains 23, contains 13. Remainder 0. So answer for this question is 0. Very beautiful problems that we discussed today. Let us go one by one. All the problems that we discussed, all the problems whatever we discussed, we will again do a recap. Wilson's theorem. Today we are going to discuss all the remainder based problems based on factorial. So if the numerator is in the form of a factorial and the denominator is a composite number, I can use Wilson's theorem. Wilson's theorem is p minus 1 factorial plus 1 when divided by p is 0. Question based on this one. Shortcut is p minus 1 factorial when divided by p is p minus 1. Example, p minus 2 factorial when divided by p is 1. Example, p minus 3 factorial divided by p is p minus 1 by 2. One example. What if it is not p minus 3 factorial? How to solve it? By using this factorization method. What if it is more than 3 deviations, 4 deviations? What if denominator is a factor of numerator? What if denominator is a product of two prime numbers 19 and 23? Right? What if the number is of the form p minus 1 by 2 factorial whole square divided by p. 71 minus 1 is 70 by 2, which is 35 factorial. Another 3 questions. Summation n into n factorial is n plus 1 factorial minus 1. Questions based on that one. Questions based on this one. I hope the entire concept is clear, right? Reminder 1. P minus 1 factorial by p. P minus 2 factorial by p. P minus 3 factorial by p. Summation n into n factorial is n plus 1 factorial minus 1, p minus 1 by 2 factorial whole square divided by p, remainder based problems, entire variety of questions which we solved it. This is how we are going to progress in every class. We will take a topic, we will do all the problems under a subtopic.